students, welcome to Hari Chemistry. Myself Dr. Hari Prasad. So today's session we will discuss the continuous lecture of salt analysis. This is the third lecture series of salt analysis. Now today's session students, we will complete the group 2 anions which belongs to the anions which belongs to this group 2 anion like Cl minus, chloride, bromide, iodide, oxalate and nitrate ion, right? So generally student, this group anion which will give a volatile products with the concentrated H2SO4 student, right? Now we will discuss this test in two category. One will be the preliminary test and one will be the confirmatory test, right? Okay, right. So from this student preliminary test, so this preliminary test we are doing a dry heating test, right? So simple students, take a clean and dry test tube. So take a clean and dry test tube, add virginal salt which is given in the given compound, right? So take the virginal salt and use the Bunsen flame heating, right? So then after few seconds, then it starts produce some colorless gas with the pungent smell, right? So this colorless gas pungent smell is released to student, then which indicate the HCl gas is produced, right? Now, so how to identify the HCl is produced, student? So just take a glass rod. So this glass rod is dipped into the ammonium solution or ammonium hydroxide solution. Then, so this glass rod used in the neck of this test tube, student. So then it will form a white dense film that indicate the ammonium chloride is produced, right? Now, so look at student the reaction of this dry heating test. The KCl is the compound which contains Cl minus, right? Now reacted with the H2SO4 followed by heating, it will produce the HCl gas, which is a colorless gas with the pungent smell. Then we are using the glass rod with the ammonium solution, then it will form a white dense fumes, right? Okay. Now this is the dry heating test and is the preliminary test, so which confirms the chloride ion is present in the given salt. Now next student, we will move to the confirmatory test, right? So in this confirmatory test, student, so just take the what chemicals required, student? Our salt solution, silver nitrate, right, HNO3 and AgNO3. So these are the main solutions required, student. Now, so take the aqueous solution of salt, or you can take the sodium carbonate extract, right? Then add HNO3 to acidify the solution. Then after heat the content up to the boiling. Then after you can add AgNO3, dropwise to the above mixture, student. Then it will form a white PPT which indicates the chloride ion is present, right? Which confirm the chloride ion is present, right? Now look at the reaction, student. The KCl is reacted with the AgNO3, simple reaction, and it will form KNO3 in the solution and AgCl as a white precipitate. Now this white PPT, student, is reacted with the ammonium hydroxide, then it will form a AgNO3, AgNH3 ties, a soluble complex it will form, right? Student, do one thing, this AgNH3 twice silver complex, again you can add with the ConHNO3, again it will form a white color precipitate, a curdy white precipitate which indicates what? Silver chloride formation takes place. This is the confirmatory test, student, very easy, right? Next we will move to the second confirmatory test, that is the manganese dioxide test, right? So take virginal salt. So this is the virginal salt, student, right? Then after you can add manganese dioxide, drop manganese dioxide here, right? Then you can add concentrated H2SO4, then heat the mixture by using the Bunsen flame, right? After heating, it will produce the pale green color gas which indicates the chlorine gas is released, right? Now look at, student, the reaction of this chloride reaction. Sodium chloride react with the manganese dioxide in presence of acid. So it will produce MnSO4 and it will give a pale green color gas of the liberation of a chloride, right? Reactions are most important, student. Just revise the reactions and easy reactions only. This is the concentrated H2SO4. Add concentration H2SO4, drop by, right? Now this is the third reaction. This is the chromyl chloride test, student. So this is the most important reaction, right? Now how to do the chromyl chloride test, student, right? So same, student, take a clean and dry test tube, add virginal salt, add a pinch of potassium dichromate, then add concentrated H2SO4, then start heating, right? So after heating, student, so this will produce a orange red color fumes, that is a chromyl chloride fumes. This is a chromyl chloride fumes, that orange red color fumes which indicates the chromyl chloride fumes, right? Now after the formation of chromyl chloride fumes, student, then add sodium hydroxide and it will form a yellow color precipitate. This yellow color precipitate is passing through the lead state solution and it will form lead chromate. So this will indicate, student, the chloride ion conformationary test, right? Now look at, student, the reaction is sodium chloride reacted with potassium dichromate and reacted with the H2SO4. This will produce chromyl chloride, it is orange red color, and forms sodium sulfate and K2SO4 water, right? Reactions are most important, student, not very tough reaction, easy reactions only, easy to remember also, right? Now this reaction is chromyl chloride, student. This chromyl chloride reacted with sodium hydroxide, it will form a yellow color sodium chromate. Now this sodium chromate is passing through the lead state solution, it will form lead chromate as a yellow color solution. Now this is the second conformationary test, and based on this conformationary test, students, we finished, right? The chloride ion is present in the given compound. Now next we will move to the bromide test, student. This is the test for bromide. Same, student, preliminary test and conformationary test. So now preliminary test we are using a dry heating test. Same, student, take a clean and a dry test tube, add virginal start, then start heating. After heating, it will produce a reddish brown pungent gas that indicates bromine is evolved. Just take a starch paper, right? So when this gas is released from here, use the starch paper, neck up the test tube, then the starch paper becomes brown color, that indicates bromine gas is released, right? Now look at, student, this sodium bromide, on dissociation it will give bromine, it is a reddish brown bromine gas is released, right? Now we will move to the second test for KMnO4 test, student. This is also a preliminary test, right? So take a test tube, student, clean and dry test tube, and add original salt, add dilute H2SO4, then start heating, right? After heating, student, then add potassium permanganate. Potassium permanganate is a purple color, right? After heating, student, the KMnO4 color is decolorized due to the formation of MnSO4. The KMnO4 color is decolorizes due to the formation of MnSO4. Now look at the reaction, student. Potassium permanganate, manganese oxidation number +7 and +2, right? So +7 to +2, it is undergoing reduction process, right? Now look at, student, Br minus to Br2. So oxidation number increases, it is oxidation reaction, right? So KMnO4 is reduced to Mn+2 and Br minus is oxidized into Br2 gas, right? Now this indicates, student, thus the given salt is contained bromide ion, right? Now we will move to the conformationary test, student, right? Now look at the conformationary test, student. First we will do to the AgNO3 test. This is the general test what we did in the earlier, that is the chloride test, right? Take a clean and dry test tube, student. Take aqueous solution salt, or you can take sodium carbonate extract. Acidify the solution by adding the HNO3. Heat the solution, heat the content, then after add AgNO3 dropwise, then it will form a pale yellow color precipitate which indicates formation of Ag bromide, silver bromide, right? Look at, student, KBr reacted with AgNO3 forms KNO3 AgBr as a pale yellow color, right? Now this AgBr is treated with the ammonium hydroxide, then it will form a silver complex of a sparingly soluble, right? Now this sparingly soluble complex, again you can react it with the concentrated HNO3, student, again it will form a pale yellow color PPT that indicates formation of AgBr, right? Now this is the conformationary test for what, student? Bromide ion. These tests are most important, student, just revise once, right? Next, now move to the test for MnO2, student, chloride, bromide, iodide, whatever the test we discussed, the same test followed by the bromide iodide. Simple, student, in place of KCl you can take KBr, in place of KBr you can take Ki, reaction will be same only, right? Now look at, student, take a test tube, clean and create clean and dry test tube, add virginal salt, add manganese dioxide, then add concentrated H2SO4 student, right? Then start heating. After heating student, yellowish brown gas is produced, that indicates student formation of bromine gas, right? Formation of a bromine, the evaluation of a bromine gas. KBr reacted with MnO2, right? So Mn plus 4 oxidation number reduced, right? Decreased, it undergoing reduction reaction. KBr, Br minus 1 to Br2, it undergoing oxidation reaction, right? So now these reactions are very, very important student. KBr is oxidized into Br minus is oxidized into Br2 and Mn plus 4 reduced into Mn plus 2, right? Next, this is one more very important test student. This is the layer test student, right? Now, take a salt solution or you can take a sodium carbonate extract student, right? Add dilute HCl to acidify this salt solution, then add carbon tetrachloride student. Some books given as a cyclohexane also, right? So cyclohexane or you can add carbon tetrachloride, right? So then after adding the carbon tetrachloride, then add chlorine water student, right? Just shake well student. After some time, then it will form a colored solution, it will form a layer. This bromine is soluble in carbon tetra. Previously it will form two layers student. One will be organic layer and one will be aqueous layer. Now this organic layer is dissolves in bromine student. This organic layer contains bromine. That bromine is present in this CCl4 solution or cyclohexane, and it will form a clear layer. So this is aqueous solution student. This is aqueous solution and this is the organic solution which contain bromine. So this is called as a layer set student. In that layer, the bromine will be present in the CCl4 only, not in the aqueous solution, right? This is KBr reacted with the Cl2 student. The chlorine is a strong reducing agent. Chlorine is a strong oxidizing agent student. This oxidizing agent, it will displace Br minus from KBr to, right, Br2, right? So this is the reaction student. Cl2 reacted with, this is the displacement reaction, right? A non-metal displacement reaction. Cl2 reacted with KBr, right? This Br minus is replaced with this Br2 and this Cl2 released as what? Cl minus, right? Now this is the layer test for what student? Bromide ion. This is the last test, right? Confirmation test. Now look at student, we will move to the test for I minus ion, right? Same test student. This is the preliminary test. It is a dry heating test, right? Take a clean and dry test tube, add virginal salt, heat the content by using the Bunsen flame. After some time, add concentrated H2SO4, right? So then it produces what student? A violet colored gas with the pungent smell, right? So this is the reaction. Potassium iodide reacted with H2SO4 followed by heating and it will produce as what student? Potassium. This will be hydrogen iodide. This hydrogen iodide reacted with H2SO4 student, it will produce I2 plus SO2 gas. Then this, when this violet colored gas is produced, then you can use a starch paper student. You can use a starch paper, right? Then the starch paper becomes a blue block complex. It will form a blue colored complex only, right? So this starch paper becomes student bluish color. The starch paper becomes bluish color. That indicates student the iodine is liberated, right? So this is the dry heating test student. Then we will move to the KMNO4. This is also a preliminary test, right? Now same student, take virginal salt, right? Then add dilute H2SO4 to acidify. Then add, after heating, add KMNO4, right? Heat the content. After heating, add KMNO4. KMNO4 is a purple color, right? After adding KMNO4 dropwise, the KMNO4 color is disappear, which indicates the formation of MnSO4, right? Now look at student, KMNO4 manganese oxidation number +7. Here manganese oxidation number +2, right? Manganese undergoing reduction, right? And look at student I minus, this I minus is converting into I2. I minus undergoing oxidation and Mn plus 7 undergoing, manganese undergoing reduction, right? Now this is the reaction, student. Similar reactions only, just recall the reaction. Reactions are very, very important, right? Now we will move to the confirmatory test, student, right? Take aqua solution, aqua salt solution, or you can take, student, sodium carbonate extract. Acidify the solution by adding the HNO3, then add AgNO3, then add silver nitrate dropwise. After some time, it will form a dark yellow color, which indicates silver iodide formation takes place. Right? Now, Ki reacted with AgNO3 forms KNO3 plus AgI. It is a dark yellow color, student, which indicate iodide formation is right. Now, this AgI reacted with the ammonium hydroxide solution, student, it will form a insoluble complex, right? Now this insoluble silver complex is reacted with the concentrated HNO3, student, it will form again a dark yellow colored precipitate, which indicate again iodide, silver iodide reformation takes place. Now next, student, we will move to the test for MnO2, right? So in this test for MnO2, student, take original salt, add manganese dioxide, add concentrated H2SO4 dropwise. After heating the mixture by using the Bunsen flame, right, it will produce a violet vapor, which indicates iodine is liberated, right. So this is the reaction, student. Potassium iodide react with MnO2 in presence of acidic medium, which will produce Mn plus 2, Mn plus 4, 2 plus 2, and I minus 2, I2. Iodide is oxidized, and Mn manganese is reduced, right. Now look at, student, then we will move to the layer test. Similar layer test for bromide ion we discussed. Here layer test for what? Iodide ion, right. Now look at, student, take salt solution, or you can take sodium carbonate extract, right. Add dilute HCl to acidify, right. Then add carbon tetrachloride, or you can add cyclohexane. Carbon tetrachloride or cyclohexane, right. Just heat the content, student, shake well, then add chlorine water, right. When we added chlorine water, student, this released iodine vapors are present in this iodine is soluble in CCl4, and it will form a separate layer. This is the organic layer, and this is the organic layer, and this is the aqueous layer. So this is called as a layer test, right. So bromine will form, student, the above reaction you can check it, student. Bromine will form this like light yellow color, student, right. Iodine will form a violet color solution, right. So this is, we can identify easily bromine and iodine easily, right. Next, student, the fourth category is what? Test for nitrate. So here also, student, preliminary test, that is the dry heating test, and the second one is concentrated sulfuric acid test for nitrate is the preliminary test, right. Now take the original salt, heat the content, then it will produce a, student, a brown colored NO2 gas is released, right, with a pungent smell, right. So which indicates nitrogen dioxide is released, right. Now just this is the salt, student, heating, then it will produce lead oxide, and production of what? NO2 gas, right. Now this NO2 gas is, right, this liberation of NO2 gas, student, for example, this is NO2 gas is produced, right. This NO2 gas is produced, right. Now take another test tube, student, just you can keep the reverse, right. Now collect the NO2 gas into here, then so this NO2 gas is present here, right. Now this NO2 gas, student, just use the freshly prepared ferrous sulfate solution. The freshly prepared ferrous sulfate solution, add to the nitrogen dioxide is present in the mixture, then it will form this ferrous sulfate, freshly prepared sulfate will be converted into a black color, right. So which indicates, student, this NO2 is oxidized, this FeSO4 into Fe plus 3, right. Now look at, student, concentrated H2SO4 test, student. This is also a preliminary test, student, right. So take salt, original salt, add concentrated HNO3, right, concentrated HNO3, then right, then concentrated H2SO4 reacted with the Salt, it will produces HNO3 vapors, right? Then add a paper pellet, student. This paper pellet is converted, it will converted into a reddish brown color with a pungent smell, right? So KNO3 reacted with H2SO4 before adding paper pellet, this will be produces HNO3 vapor. After the formation of HNO3 vapor, student, then we are adding a paper pellet, right? So which contain carbon, right? This carbon is converted into carbon dioxide. This HNO3 plus 5 will be converted into plus 4, undergoing reduction process, right? Now, so when this carbon undergoing oxidation process, that paper pellet will be converted into, it will reacted with this, and it will produce a reddish brown colored gas, student, with a pungent smell, so which indicates the nitrogen dioxide is present in the given compound, it is releases, right? Now, conformational test, student. So this is the diphenylamine test, right? Take the salt solution, add diphenylamine, then after some time this will be oxidized, diphenylamine oxidized, and gives a deep blue color solution in presence of nitrate ion. In presence of nitrate ion. So this is the diphenylamine test, student. The color is most important, that diphenylamine is oxidized and gives a deep blue color solution, that indicates the presence of nitrate ion. Okay now. The second test, student, copper chips test, right? Take virginal salt, add concentrated H2SO4 dropwise, then heat the content by using the Bunsen flame, right? After heating, then it will produce HNO3 vapors, right? After formation of HNO3 vapor, then you can add copper chips, student, right? A copper pellet, copper chips you can add and heat using the Bunsen burner. The copper chips reacted with HNO3 and it will produce a brown colored gas. Reddish brown fumes are coming, that indicates NO2 is released, right? Right. Next, very important reaction, student. This is a brown ring test, student, right? Now look at, student, this is the most important reaction, right? Take aqua solution, salt solution, or you can take sodium carbonate extract, right? Add freshly prepared, right? First add freshly prepared FeSO4 solution and add concentrated H2SO4 slowly, right, on the walls of the test tube, right, forms nitronium complex. During the reaction it forms nitronium complex, right, which appear, this nitronium complex which appear as a brown ring, so which appear as a brown ring in the test tube, right, which indicates the formation of a brown ring test, student, so which confirm that compound is contain nitrate ion, right? This is the reaction, student. KNO3 is our salt, reacted with the H2SO4 forms HNO3. Now this HNO3 is acidifying by using the H2SO4, by adding FeSO4, this Fe plus 2 is oxidized into Fe plus 3 and HNO3 plus 5 will be converted into plus 2, right? Now this FeSO4 reacted with the nitric oxide form a brown ring complex. This is the most important. This is the brown ring complex formula, right? Reactions are very, very important, student. Brown ring complex reaction questions are asking here, right? Next, last, student, test for oxalate, right? So this is the preliminary test. This is the dry heating test, right? The same process, student. Take the clean and clear test tube, add virginal salt, heat the content, it will produce the colorless, odorless gas which indicates CO2 gas is produced. Now, so take one more test tube, student. This produced CO2 gas collect in a clean test tube, then add lime water, so that is CaOH twice, then it will form a milky white precipitate, so which indicates carbon dioxide is reacted with the calcium hydroxide, they will form a milky white precipitate, right? Next, student, KMNO4 test, right? Take the virginal salt, add diluted H2SO4, after heating add KMNO4, right? This KMNO4 purple color will be decolorize the formation of MnSO4, right? This is the oxalate, our salt, reacted with the H2SO4, formation of a Na2SO4 with the liberation of oxalic acid. Now, this oxalic acid, this is H2C₂O₂, student. This is H2C₂O4. reacted with this. Reactions are most important, student. KMnO4 plus 7 and manganese will be plus 2. Here carbon oxidation number plus 3, carbon oxidation number plus 4. Reaction, stoichiometric coefficient, everything is very very important, student, because redox reaction also questions are coming from here. So 2KMnO4 reacted with the oxalic acid in presence of acidic medium produce MnSO4 and liberation of carbon dioxide gases, right? Reaction is most important, student. Practice the reaction, right? Now we will move to the concentrated test, student. Concentrated H2SO4 test, right? Take virginal salt, add concentrated H2SO4, right? If our salt containing oxalate, this oxalate reacted with H2SO4 and it will form carbon dioxide and also carbon monoxide. So right, so this will converted into, it is a dehydrating agent, it will leave the water molecule, then it will produce carbon dioxide plus carbon monoxide also, right? So take another fresh or clean test tube, collect the CO2 gas, add calcium hydroxide or lime water dropwise, then it will produce calcium carbonate, right? So which confirms that oxalate produces carbon dioxide, right? Next, student, confirmatory test. This is calcium chloride test, right? Take the aqueous solution or calcium sodium carbonate extract, right? Add dilute acetic acid, boil the content, right? To boil CO2, then add calcium chloride. It will give a white precipitate, right? So this is ammonium oxalate reacted with the calcium chloride, it will form calcium oxalate. This calcium oxalate is what, student? White PPT. This white PPT again reacted with calcium nitrate concentrated HNO3 and it will form a soluble calcium nitrate. Again it will produce what, student? Oxalic acid. So reactions are most important, student. Just practice the reactions for examination point of view, right? Now that's it, student. So these are the confirmational test for the oxalate ion, student. Revise the lecture, right? Without skipping, student. Continue, watch the lecture, write the reaction, pause the video, write the reaction and practice the questions from the mains point of view or see the advanced level question, student. 100% you will get the answer, student, without any doubt, right? I hope, student, this lecture is suits for you. So please subscribe and like, right? So please like the press button, student. That is very very important. It will reach us to many people, student, right? That is also help for me, right? Thank you, student.